Welcome to PreMath. In this video, we have got this parallelogram ABCD that consists of a bunch of smaller parallelograms, as you can see in this diagram, such that the area of this green parallelogram is 144 centimeter square. The area of this blue parallelogram is 48 centimeter square. And finally, this yellow parallelogram area is 108 centimeter square. And furthermore, this diagonal BD passes through points N and R. And now our task is to calculate the area of this big parallelogram ABCD. Please don't forget to give a thumbs up and subscribe. Please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our action plan. In order to calculate the area of this big parallelogram ABCD, we must first find the area of all these smaller individual parallelograms. And eventually we are going to add up all those individual areas. Before we proceed, let me go over the basic concepts. Here we got a rectangle. And let's assume the area of this rectangle is 10. And if we draw this red diagonal, then this rectangle has been divided into two identical triangles. So therefore, the area of this triangle is going to be 5, and this is going to be 5 as well. They have the same areas. And now let's focus on the parallelogram, and let's assume the area of this parallelogram is 10 as well. Then this red diagonal is going to divide this parallelogram into two equal triangles. In other words, the area for this triangle is going to be 5, and this is going to be 5 as well. They are going to be congruent. We are going to apply this concept on these three parallelograms, this one, and this one. And here's our very first step. Let's focus on this parallelogram DENM. And we can see that this diagonal DN is going to divide this parallelogram into two congruent triangles. Let's assume that this area for this triangle is lowercase a, and this one lowercase a as well. And now let's focus on this next parallelogram NPRT. And we can see that this red diagonal is going to divide this parallelogram into two identical triangles. Let's say that the area for this triangle is lowercase b, then this is going to be lowercase b as well. And now let's focus on this next parallelogram RHBJ. Likewise, the area of these two identical triangles is same. If the area of this triangle is lowercase c, then this is going to be lowercase c as well. And here's our next step. Let's focus on this big parallelogram DFRL. We can see that this red diagonal is going to divide this parallelogram into two equal parts. This one on this side, and the other one is on this side. And we can see that this area equals to this area. This one is same as this area. So therefore, this parallelogram area is going to be equal to 108 centimeter square. So therefore, the area of this parallelogram turns out to be 108 centimeter square. And now let's focus on this another parallelogram GBKN. And likewise, this red diagonal is going to divide this parallelogram into two equal parts. This one, this triangle, this area, and this area as well. And now we can see this area is same as this area. This area is same as this area. So therefore, this area is going to be same as 48 centimeter square. So therefore, the area of this parallelogram turns out to be 48 centimeter square. And now let's focus on this next parallelogram EAHT. So before we proceed any further, let me go over this basic concept. Here we got these two rectangles, the yellow one and the blue one. The area of this yellow rectangle is A. The area of this blue rectangle is B, with the same height h. with their respective side lengths lowercase a and lowercase b. Then we can write the ratio of their area is going to be equal to the ratio of their side length. In other words, a divided by b is going to be equal to lowercase a divided by lowercase b. So we are going to use this concept on this parallelogram. Let's focus on this green parallelogram and this next parallelogram, and we can see that their area ratio is 3 to 1. In other words, if I divide this 144 divided by 3, I'm going to get this number 48. And now likewise, I'm going to divide this 108 by 3 to get this area. We know 108 divided by 3 is 36. So therefore, the area of this parallelogram turns out to be 36 centimeter square. And now let's focus on this another parallelogram FRLD. And now let's focus on these two parallelograms. And we can see we can get this area by just multiplying this 36 by 3. So that means we are multiplying by 3. So likewise, I'm going to multiply this 108 by 3 to get this area. I'm going to multiply by 3. So 108 times 3 is going to give us 324. So therefore, the area of this parallelogram turns out to be 324 centimeters square. And now let's focus on this next parallelogram GBKN. And now let's focus on these two parallelograms. And now we can see their ratio of the area is going to be 48 divided by 36. And if we reduce that thing, we can get 4 divided by 3, isn't it? So therefore, we can see if we multiply this 36 by 4 divided by 3, we are going to get 48. Now likewise, we are going to multiply 48 by 4 times 3 to get this area. Let's go ahead and multiply 4 divided by 3 times 48, and that is going to give us 64. So therefore, the area of this parallelogram turns out to be 64. And finally, let's focus on this parallelogram PJCM. And let's focus on these two parallelograms once again. And as we did in our previous step, if we multiply this 36 by 4 divided by 3, we can get 48. And now likewise, I'm going to multiply this 108 by 4 divided by 3 to get this unknown area. Let's multiply these numbers. If we multiply them, we are going to get 144. So therefore, the area of this parallelogram turns out to be 104 centimeters square. And here's our final step. Let's go ahead and calculate the area of this big parallelogram ABCD. And that is going to be equal to the sum of all these individual areas that we figured out in our previous steps. We're going to add them up all these numbers. And here in this next step, I have added up all these individual areas of these parallelograms. And if we add all these numbers, that is going to be equal to 1024 centimeter square. So thus the area of this big parallelogram ABCD turns out to be 1024 centimeter square. Thanks for watching, and please don't forget to subscribe to this channel for more exciting videos. Bye.